AP Chemistry Topic 3.7, Solutions and Mixtures. So first of all, let's talk about a little vocabulary. To begin with, a solution is a mixture that is very evenly dispersed. And so generally this happens with particles that are small relative to everything else in the system, whereas mixtures are things that might be a little bit larger. So if you think about terminology here, a solution is homogeneous and a mixture tends to be described as heterogeneous. So let's dive in a little bit more to some vocabulary here. So in solutions, we have two components of a solution. We have the solvent, which is the thing that's doing the dissolving, and we have the solute, which is being dissolved. And the solvent plus the solute is equal to the solution. So then we can actually quantitatively describe that in terms of something that we call concentration. So concentration is a measure of the amount of solute in solution. One way to denote concentration is with brackets around whatever the thing is that we're talking about the solution of. So for example, if we had bracket Cu2+, that would be the concentration of copper 2+. So then the unit that we use most often for this is molarity, which is moles of solute over liters of solution. So we can express molarity in a couple different ways. We can call it molarity, we can use that capital M, or we can say moles per liter, and you will see all three of these. Important to note that the liters of solution here is the total volume. So when you add the solute, if that increases the volume of your solvent, which can happen, then you need to make sure that you are using your total volume there. So then we can also talk about dilution. Dilution is a process you're probably familiar with. That's when you add more solvent to a solution to decrease the concentration. And we can use this equation here. M1V1 is equal to M2V2. Now, important to note that your moles are equal on both sides. So what we're doing is we're changing the proportions by changing the volume of the solvent, and then that changes the molarity accordingly. So if your volume is lower, your molarity will be higher. Now, one thing I want to point out to you here is that this equation, this molarity, is equal to moles over liters. That is on the equation sheet, whereas this one is not. So if we look at the equation here, here's your molarity is equal to moles of solute over liters of solution. And if you forget what things are, the variables are defined on this side. The dilution equation is not on here. You do not technically need the dilution equation to do dilution calculations, but it does make it a little quicker. So there you go. That's all about solutions.